Morning, everybody. How bad does this look? How loud is the audio if you happen to be online? Sounds good. That's good. The Windows update came along and broke everything for Streamlabs. I wish I could show you my lovely setup I've got now. So whatever happened in the Windows update, I can no longer run my Streamlabs with my NVIDIA card, which is what it needed to do before to get the secondary desktop running. So now I've got my laptop sitting on top of one of my kids' chairs because that's the only thing that will support my my webcam. It's delightful. Be right back. And we're back. Just in time. Everything is broken. Oh, man. Okay. Let's go ahead and get started. So I am happy that we are able to have class today. I wasn't sure if we would or not, but I'm okay, which is good. A lot less bad than the last vaccine injection was. First time I must have just had a really good migraine or something going on. All right, taskbar, go away. Okay, good. So let's see. Today is Friday. We have a little bit of time before the homework is due, but just as a refresher, April 2nd. So hopefully that's okay for everybody. Solid week and a half should be okay, I would hope. Full screen. Good morning, how was your shot? It went very well. They run, so I went over to DeVos down in Grand Rapids and very well organized, very smooth, in and out. It was great. Um, for me, I reacted, so I tend to get headaches anyway. And I think I reacted with a pretty good migraine, and that's pretty much what I got. But I think that's what I really had last time, just a really bad migraine. All things considered, not horrible in the least. I know there is some of the other faculty went and got it too, and I think more or less everybody's okay. So yeah, I'm happy to not really have any side effects. Real ones anyway. I know some people react, some people don't get anything. So we're here today. That's what counts. I'm fresh and frosty and just mad more at Microsoft than anything else right now. Their silly update broke Streamlabs. Actually, I think their silly update broke NVIDIA, which broke Streamlabs. Any of you are Streamlabs experts, by the way, I'm more than happy to solicit your feedback because the internet doesn't know anything about it. Um, just for funsies, I don't know if any of you are streamers, but what I used to be able to do is right click on Streamlabs and then run with NVIDIA because my GPU apparently is the only thing that can handle multiple displays easily. Options just disappeared from here. And setting options in the control panel just doesn't do anything. So, mildly new setup. Also broke all my audio as well, so I'm not going to be able to do the Discord voice chat um, live while doing class anymore either, it seems. Anyway, those are my problems, I suppose, not yours. So, we were talking about COCOMO last time, and it was really just kind of a nice little empirical model for calculating effort and an estimated schedule, right? Excuse me. So we had the three modes, basic, intermediate, or advanced. We also had three development modes, organic, semi-detached, and embedded. And these factor into a cost effort estimation equation. So this is pretty much where we left off, right? We can calculate out based on some figures that we look up in a table and get the amount of person months that a project will take. And again, we would calculate them based on where we are in our project, based on how much information we have, things of that nature, right? So we kind of ended right here where we started talking about the cost drivers. Now, the cost drivers are going to be related to the product, to the computers, to the personnel, and to the project. And we have 15 of them in COCOMO 1. So what are these things? Well, we have product cost drivers, which goes into features like reliability. So how reliable does our project have to be? And this could be anything from safety critical to uptime to things of that nature. How reliable is it? We may have to deal with a database. And if you have a database, how big is it going to be? How complex is it going to be? How complicated is the product itself? And then we get into our project costs. So what are the tools we have? What's our development schedule looking like? Our programming practices. And then we have some more for the other ones as well. So like execution times, do we have storage constraints? Kind of all of these things which may impact, say, a computer that you're building. And then personnel. So what are the capabilities and experiences of your various team members? If you are let's take a look at this last one, just to kind of zone in on it. If nobody on your team has experience writing, say, Java or C Sharp, and that's what the project is in, it's going to be a lot harder to build the project because there's a lot of front-loaded learning time, right? So this is where a driver like, you know, language experience would come in, where it would kind of skew your model towards, well, we need more time for learning Java or learning whatever technology that we have to build here. Maybe you are building something that needs a virtual machine. So it could be an IT-based task where you're setting up VMs. If nobody's ever run VMware, or if you've never been on a cloud provider before, you probably have zero virtual machine experience, and you have to, again, learn this. But again, these are going to basically be lookup table type figures. So we're going to treat them basically as like symbolic math. So this would be a plug-in type value, your variable X, variable Y, things of that nature. Okay, so before we calculated out effort, and this is based on how many kilolines of code you have times some cost driver. This is now going to plug into our schedule. So if you remember, effort was how many person months. We also got the schedule out of COCOMO. This is going to be our TDev, or development time, in months. And it's going to be a multiplier times the effort that we calculated out times an exponent. And again, these are just kind of plug-in values based on some table here. So if we're going organic, we're going to see this 2.5 and this 0.38 here. There's our 2.5, there's our 0.38. And this is going to be our C times size K. So here's our C. And this is our K. It's a slightly different table. But really, just kind of plug in values and then you get the person months out of it. Make sense so far? The shot was fine. My allergies are driving me nuts today, though. Seems just getting a thumbs up. Good to hear it. You'll love to see it. And we don't want to right click because that breaks our presentation. Okay. All right. So let's say that we have a full screen. There we go. So we're calculating out effort and project time for a simple project. All right. So here we are doing COCOMO 1. It is an embedded system, and we're using the basic model. So we're not bringing in any of the extra cost drivers here. Effort is going to be, again, 3.6 and 1.2. These are values that we grab out of our table. So basically we look, what is the basic model? What is the embedded model? Okay, so our multiplier is 3.6, our exponent's 1.2. How many kilolines of code do we have? Well, it's about 10,000. 10,000 lines of code, so that's 10 kilolines of code. Our effort that we have to do is about 58 person months. Right, so this is what we can expect to have to deal with. All right, well, that's fine. Now let's apply that to our other formula here. And grab our tdev, and again, we're going to pull these values here, this C and this value K, out of our tables. And again, that Geeks for Geeks website has a pretty good set of lookup tables. I don't have anything outside of what we've got in the slides here, but if you want to kind of go through that site's got a pretty good example. Anyway, 2.5 times, we'll grab 58 times 0.32, that's about 9 months. And what you can do as well is you can divide these out. So we can say divide 58 by 9, get the number of people that we think we're going to need. So if we have 58 person months and it's going to take us about 9 months altogether, we're going to need about 6.44444 people. Right, so what's going to happen then is that we'll probably err on the side of caution and try to hire 7 people. But, you might make the argument that you could get by with 6 if you kind of overload them with work. But very basic feel for staffing and for resource allocation here. Again, here's how much effort in person months it's going to take. Here's how much development time it's going to take. We can just divide it out to figure out how many people we think we are going to need. Is this enough information? It's kind of hard to tell, right? Very basic model, not taking any of those extra drivers into account here. That we're not taking into account, are we doing, something complicated? Are we doing something that requires real-time execution constraints, or are we dealing with storage constraints? Is a project super complicated, or is it a basic, embedded system where there's not a whole lot going on? Just kind of depends. But you don't get that reflected in this particular view of the model. So, question to you all. I don't have a slide for this or anything, but let's say that you take a COCOMO 1 model, and this is again what we're focusing on here. If you go with a more complicated view, so if you do the advanced, which takes into account, all of these cost drivers, do you think we're still going to get a correct schedule, a correct estimated effort? And if yes or no, why do you think that? So, question in chat. It'll be rough. Yeah. So that's a good point. Better than throwing darts at a dartboard. To me, that's kind of what the basic model feels like, though, too, is just tossing darts. Again, this might be, I don't know how hard this is for you to visualize or not, right? Based on your experience with programming and working on teams. But at some point, you will have to plan out a project. If you're in industry for a little while. No, it doesn't account for the experience, unexpected accidents, but it's better than nothing. Yep, absolutely. Again, it is a empirical model. It is an estimate based on past information, based on other projects, and based on what you, the analyst or the project manager, thinks is going to happen. Sometimes it's hard to determine how much code, so it'll be hard to know what to put in the equation. Also true. Yep. So that's a good point too. Maybe you realize you have to switch programming paradigms or you have to add in a new module, and that requires a lot more effort than you expected. Absolutely. So yeah, definitely all good points. And the issue that you may find is if you start doing things like estimating what's going on and trying to figure these things out, at some point when the model breaks down or when your estimate breaks down, what do? Well, we can go in and we can recalculate things. We can refine our estimates and really try to see what's going on with the project. And again, keep in mind too, with these models, this is not something that you do once and you're done. You refine them as you go. Right, so every step of our software development lifecycle, we have more information. We can refine our estimate and then realize, let's say we get our requirements and our design done, we're getting into implementation, we realize, oh crap, we need 2 more people to cover the GUI because now our customers decided they want a React interface instead of just a straight up responsive basic website. So changes in the project, changes in experience, maybe somebody quits, somebody who is critical to the project, maybe they're gone. It just kind of depends. Basically, we have to be flexible with these kinds of things. So I've got some nice big bold font for you here. So the time required to complete a project is a function of the total effort required for the project. So that's one point. So the effort and the total time are inextricably linked, but big bold font here does not depend on the number of engineers working on the project. So this is a big angry old man shaking his fist at the camera. Do not throw more people at a project thinking it will get it done quicker. Don't be that project manager that thinks you can just solve a problem by throwing more bodies at it. It never works. It actually, there's lots of studies out there that if you realize that your project is going to go over your estimate and you think, okay, well, we'll just add more people onto it. More often than not, it will actually take longer. And why is that? You have to onboard those people, you have to get them up and running with the project, get them trained, bring them onto the team, and there's actually going to be a lot more effort than if you had just helped out your current team members. So don't throw more bodies at a problem thinking it will solve it. This is, if any of you have started reading Dilbert or anything like that because you're planning on going into industry, or there's probably XKCDs about this too. Um, a running joke in industry. More bodies does not mean quicker resolution time. Dividing the effort by the schedule does not give useful indication of the number of people required. So this is a good point too. So a few slides ago, I told you you can divide 58 by 9 and get 6.4 people, and that's how many you need, right? That is good as a initial guess. This is not a golden rule that you can go by. Again, I think it was Sarah's point there. Um, it doesn't take into account the experience of the team, how long they've been working for your company, what their backgrounds are, their ability to work together, right? We can't just plug in an equation and get a project. You have to be a human being and understand what your project team is capable of, right? Maybe you have a very complicated project and you have three absolute, complete experts, and they can get the job done in the correct amount of time. Or maybe you have those three experts and they just fight like cats and dogs and they make zero progress because everybody has a very specific way they need to do something and they keep unintentionally undermining the other people. Again, there's a human element to this that you have to kind of keep up on, keep refining. So don't think more people equals quicker. Any other thoughts to this? I'm telling you this is true from experience, but I'm curious if anybody else has experience with this kind of a point here. Step off camera for a second here. Try not to be too gross on stream. I love allergy season. All right. There's a well-worn joke about having babies and having splitting it up amongst nine mothers, and won't go into that one, but you'll probably hear that one at some point going into industry. That's exactly right. So more time to bring everyone up to speed if they added workers towards the end of Cyberpunk. I could see that. I also saw a quote the other day saying their initial estimate was 2019 for a release for Cyberpunk. So at least they had an extra, bit of time to flesh things out, but I've heard it's better these days, at least. If you can get used to the jank, I think. Maybe I'll try that one over the summer. We'll see. Okay, so this was COCOMO. And again, this was COCOMO 1. COCOMO 2 adds on a little bit more complexity. It takes into account newer programming paradigms and newer concerns, but it's still at its core, it's a pretty similar model. It's just the formulas are a little bit more complicated. One other thing that we're going to look at is earned value analysis, or EVA. And this is another way of basically modeling progress, of modeling your project status. And if you go this route, it kind of helps you quantify your project and where it is at. So you can be the project manager who says, I feel like we are over budget, or we are overstaffed, or we are way behind schedule. And somebody else in the company is going to ask you, okay, well, how do you know that? And you would say, well, I don't know. Um, if you want to have a set of hard numbers behind that gut feeling, EVA is the way you're going to go. And the spoiler or the forewarning here is that we are going to kind of zip through this a little bit. I mean, it's gonna feel like I'm glossing over a bunch of things, but basically there are a lot of kind of again, like more of a symbolic type of math that we're going to be focusing on here. just the key takeaways, there's a lot of acronyms to keep in your mind, and I'll try to keep reminding you of what some of these are, but there is a lot of them. Um, but anyway, EVA, to get going with acronyms already. So the only way this works is if you have um, a list of tasks for your project, and if you have a set of costs and resources and rates that have been allocated. Basically, you need that Gantt chart for EVA to work is kind of the key takeaway here. Or you can do, burn down and burn up, but it's just going to be the numbers will be a little bit different. But quantitative scheduling is what we're getting at here. So this is where the acronyms start. Look at all of these acronyms. What do we need with EVA? We need the budgeted cost of work schedule, which is basically summing up the cost for each work task. We need the budget of completion. We need the budgeted cost of work performed and the actual cost of work performed. So basically, we're going to take a Gantt chart. We're going to export all of the costs and all of the efforts for each task that you have in your project. And if you've started doing, hopefully, the group work with your project task development and all of that fun stuff, you might be starting to see these numbers creep in. I didn't ask you to put them down, right? I didn't say how many, person months is multiplayer going to take, or how much salary is the front end going to cost your teams, or something like that. But you can get these values out of Gantt charts and out of our various scheduling tasks. So the budgeted cost is basically how much have we estimated for the work, and then how much did it actually cost. Again, how much we budget and how much something actually was can be two different values. So we're going to basically get a sum of all of these out of our project. And given those four values, we can calculate progress indicators. And this is where things start looking, again, a little bit symbolic. Just pretend this is like x, y, x divided by y, x minus y, x divided by c, x, y, z. So, no, z divided by, I'm already lost in my symbolics here. Basically, these are acronyms for everything that was on this page here. So what we've got are a few indicators here. Well, not a few, this is several. We can figure out the schedule performance index, the variance, the percent scheduled, the percent complete, the cost index, the cost variance. And these aren't complicated calculations. Again, remember that these values here are all basically sums out of our schedule. And it's just whether we're dividing them out or we're subtracting them to get variances or percent completes or things like that. So what are these things? Well, our SPI, or performance index, will tell us, are we ahead or are we behind schedule? So if it's greater than 1, we're ahead of schedule. Life is good. If it's less than 1, we are behind schedule. Oh shit, what are we going to do? And again, basically, keep in mind these are costs budgeted for work task. Some of all of those actually done. Again, this is cost and effort and completed. And by having ratios or divider or subtractors here, we can actually get these values. It looks more complicated than it really is. Think of an Excel sheet where you just highlight a column and hit sum column. All right, so our CPI then, greater than 1, we're under budget. Again, life is good. Less than 1, we're over budget. That's bad. And that's our cost performance index here. We're ahead of schedule, we're behind schedule. Under budget, over budget. Again, what's the purpose of these? It is to categorically say where you are at in a project. And to be honest, if you go with I want to say like a more feature-rich tool, it's been a while since I've touched Microsoft Project, to be quite honest. That's been slightly intentionally. I'm pretty sure you can actually get this right out of Project, if I recall correctly. And if not, it is a very easy calculation to do. Again, just dividers and basic math. So what are we going to do, and why would you use this? So let's do a example here. So assume you're a project manager. You've been asked to compute EVA for a small project. You have 56 planned work tasks. You're expecting 582 person days to complete those 56. At the point in time where I ask you to do EVA, 12 have been completed out of the 56. However, based on our schedule that we have created, 15 should have already been done. So you're going to look at this paragraph here, and before you even calculate out anything, you're going to feel like things are behind, right? You, the project manager, I see 12 tasks done, meaning I go into my configuration management tool and I look at all the work packages that are assigned to people, and I see 12 closed, 15 should be closed at this point based on a Gantt chart that we've created. Right, so we feel like we're behind schedule. What do? Well, let's calculate out all these values that we have talked about, right? So here we have our 15 tasks that should have been completed. Here's the planned effort for them. Here's the actual effort. So task 1, we expected, say, 12 days. Took us 12 and a half. Task 2, we expected 15 days. Sorry, person days. And this was, yeah, so these are person days, not just days. Took us 11, so we were actually ahead on task 2. Task 3, we expected 13 person days. It actually took us 17. So this one was kind of a killer in terms of complexity. 4, expected 8, took us 9.5. So you can kind of see a trend here, right? What we plan and what actually happens is probably never going to line up exactly. It's just kind of the way of things, right? Maybe somebody's having a bad day. Maybe something's more complicated than we expected. Maybe something's less complicated than expected, right? The actual effort's never going to line up, no matter how good you are at predicting or analytics. Okay, so we have this table, and again, this is something that you could export out of your project management software, your Microsoft projects, or um, even you can probably get some of this out of your configuration management tool as well. So based on our problem statement, we expect 582 person days in total. Now, the sum of our numbers from the planned effort column, and that's this guy here, is 156.5 in total. So for the first 12 tasks, it was 126.5. From the actual effort, it was 127.5. So these last two here, sorry, this is the first 12. This is all numbers. This is all numbers. From this particular example here, we're not looking at the whole project at this point. We're just looking at kind of where we are at project-wise, along the timeline here. So what do we calculate? And I've got all the acronyms here on the right, so I'll try to keep these up for you. So our SPI is 0.81 based on what we're calculating. And again, this is the 126.5 is the actual numbers for planned for the first 12 divided by 156.5, which is the sum of all of our numbers. So these are planned, and what this is 0.81. And if we remember, which is probably hard to remember at this point since I'm throwing all these acronyms at you, if you are less than 1, you are behind schedule. So we are very clearly behind schedule here. Our SV, this was our schedule variance. This was negative, basically it's our subtractor here. We are in the negative 30 person days. SV being less than 0, we are behind schedule. And what does this mean? We're behind by 30 person days. PSFC, this was our percent scheduled for completion. We are at about 27%. Our PC is the actual percent complete, 21.73. Again, we can very clearly see that we should be here and we are here. And if you're looking at this like a project manager, or you're looking at this like a business manager, you are seeing just raw data that says we are behind. Our CPI and CV, so CPI was cost performance index. Um, it is 0.99. We are under budget, or sorry, we are over budget. In our CV, this is our cost variance. Less than 0, we are over budget again. So we have a whole bunch of metrics here saying we are behind. And you can use this hard data to actually convince people that things need to be done to move forward. And this is going to be one thing that is all going to be useful for you all to kind of take and internalize, that you can't just bump up and escalate problems to the next layer of management on your gut feeling. Okay, if you feel like your project is behind schedule or it's over budget or things are not going right, you can't just say, hey, we're behind, what do we do? You actually need hard data and metrics to convince people that, yes, this is a problem. And what do we do at this point? Okay, we're behind in 30 person days. We are not at the percent complete that we need to be at this point in time. And again, we are looking at things at a broad, far out view where, okay, we need to be here. And if we're not here, our project and tasks are going to be pushed back as well. So if we have data like this, we can try to regroup and reorganize and see what can be done to fix our project. So, question for you all, this isn't in the slides. What do you do to fix this? So we are way behind, right? Um, we're over budget, currently over budget. We're not, we haven't completely blown out the budget, but we're not in a good place. We're behind schedule. Overtime. Okay, so that is one option. We pay people for overtime and make sure that you are the manager that pays people for overtime. Um, project lead, scope back. Hey, these are all good points here. Let's start with overtime. There is this unspoken agreement when you are a salaried engineer that overtime is just something that happens and you don't get paid for it. Don't be the project manager that expects that. Be the one that actually pays overtime, because just because you're salary doesn't mean that you should be expected to work more than 40 a week. All right, negotiate with the customer for more time. Okay, so that's one point. That's a good aspect, right? Based on your requirements, we are a little bit behind. Maybe we need more time. Maybe we need something more from you, or maybe your requirements are so ambiguous that we fell behind trying to interpret them. Project lead, step in and fill a role. That's a good point too, right? I am already filling the role of managing this project. Maybe I have the time and ability to help out as well. Scope back. So it could be that we've bitten off more than we can chew. This could go into renegotiating with your client as well. Again, it kind of depends. If we all work a weekend, is the cost benefit of doing that and paying people the overtime better than being late by a week or something like that? Just kind of depends. Kind of the key takeaway is that it's gonna be it's gonna be a tough decision at the end of the day. Do we bring on a contractor? Do we hire an intern to help out? Do we add a person at an early stage? Right? Is that going to kill our budget, but are we going to bring our project back in line? I like the project lead bring in or step in. That might be a good solution here. Okay, so that was EVA. And again, I'm not expecting you to memorize all these figures. We also don't know if other tasks will take less time in the future. That's true as well. At this point, you would probably want to reevaluate your project estimate too. So if you are, let's see, we are how many days in? 15 days in, or sorry, 15 tasks in, and we have 56 in total. That's really not all that far into the project, right? Maybe it's front loaded with hard ones, and we didn't catch that with our early estimates, so it's possible we have to reevaluate. And if we determine that based on the rest of the tasks and what we know now that we need 2 extra people, well, it's better to onboard them early rather than throw them on at the very end, right? So yeah, good point. Okay, so with EVA, with COCOMO, again, these are well-worn algorithms or kind of Excel-based tasks that you would have to do. Not a whole lot of craziness in actually calculating them out. So just a quick touching base type of thing here. For your next homework assignment, you have to do a project plan, right? So what are your tasks? What is the approximate time? What do you have left to do? Any questions on expectations for this? And again, I've got links here for how to, say, create a Gantt chart if you want to do it in Sheets. Or burn down and burn up. End up with figures that look kind of like this. So I've got a brief example for you all, just to kind of get you going. It's open source tools. So this is actually from last year. The issue that I have when I do little term projects along with you all is that if I tell you what I'm doing and where I'm at, for some reason I stop working on it. So last semester I was working on a roguelike game in Pygame with entity component system for the programming paradigm, and I was bringing in some procedurally generated text, and it was very beautiful. And then I stopped working on it because I got busy. But what I kind of did for this was that I had a proposal for my project. I created some use cases, and this is where we're at right now. And now you kind of have to figure out what is left to do. So if I need a Pygame interface, okay, that'll take me a week. I'm building up a tile map that'll take me one day because I know how to do tile maps, sprite sheets, um, other stuff. I can kind of estimate the amount of time left for that. And then, okay, I'm the student here. What tasks do we have left to do? Well, we have homework that the professor is still assigning, so maybe that'll take us 3 weeks. We have this requirement spec, which we know is our final deliverable, which again, you already have made progress on by the midterm. And then you have all of your extra things that you have to be doing. So number of weeks, number of days. So basically, I'm just kind of looking for you all to think about what the tasks are that you have left to do and assign effort to them, whether it's days or weeks. And try to also assign somebody responsible to those as well. And that will basically be how you create your Gantt charts. You're going to have a line item, you're going to have a number of days, and then that will basically determine what it looks like in the Gantt chart or in your burn down or burn up chart. So kind of what we're looking for here. So if we are all good with that, we can move on to UML for the last 10 minutes. Everybody good? Questions at all? About Zelda and chill? All right. If we're good, let's talk UML. So we are done with project management and project planning outside of your homework that's due. All right, now we're going to get into UML. We're going to get into design patterns, and it's going to be fun. And after we get through that, we're going to do test-driven development, and you'll get some more experience with JUnit if you didn't before. But UML. Hey, taskbar, go away. Go away, taskbar. Okay. Present. There we go. So we talked a little bit about modeling before, right? Okay, now it's gone. We got started, we talked about some of the different models that we have to deal with, and we focused on use cases, because that's a good early project thing to do. Well, I mentioned briefly in passing before that there's a lot of other models and that we would be taking a look at a handful of them. And this is that time now. So we are going to be looking at UML kind of as a whole today, and then next time we'll go into some of them a bit deeper. And this set of slides is mainly class diagrams, object diagrams, and sequence diagrams. I think you all got experience with class diagrams in Java, if I recall, from my poll of all of you before. But we'll go into it here as well, because it's part of UML. All right, so let's start off with what is modeling. Modeling outside of possibly a very debatable usefulness in industry type of question. Um, you're going to get people who hate UML and who you love UML when you go into industry. Also people who have no idea what UML is. But for us, it's a simplification. So it is going to be used as a communication point, right? So a use case diagram is not necessarily how things actually are, right? A sequence diagram might not capture the minutia of how things happen in your system. We are simplifying, and we're doing it so that we can understand what you're building. It is an effort that you should go through at least once in a project because, again, just talking or sending emails or writing requirements, it's not always going to capture interactions. It's not always going to show you the big picture. If you model something out, you can very easily see visually that component A and component B are actually linked up together, right? It turns out that we have these two separate subsystems and we had no idea they would interact. But crap, simply by putting them on the same network, they're actually talking to each other and we didn't anticipate that. So by modeling things out, you can better understand things. That's kind of the key reason why we do this. And every one of these models shows you a different aspect to a system. And you don't have to do all of them, right? You don't have to be experts with all of them, but you should kind of understand kind of why we would use one over the other. And maybe modeling is something that you come back to. If you start seeing, okay, maybe your project's just getting too complicated, maybe you're starting to see weird behaviors in your prototypes, maybe your requirements just don't make any sense. If you come up with a model, you can at least try to understand what you're building, right? So we're getting some blueprints here for our system. And we talked about this before, but we can look at it structurally or behaviorally. So structurally is how everything is organized, it's how it's set up, it's how it's constructed, right? These are going to be your class diagrams. These are going to be things which tell you how to build the system. The other side is the behavior. That is the dynamic interactions. That's your expressed behaviors. It's going to be sequences of things happening or how system A talks to system B and what system B now does now that it has new information. Lots of hand waving today. Sorry about that. um, but structure versus dynamics, basically. So what do we get for modeling? Let's put all these up here. So we can visualize the system. And again, this is a very important task to be able to do. If you, let's take kind of maybe the backwards approach to talking about this. You go into industry, right? And I assume that's what maybe everybody's path is. And if not, that's fine too. Good information to have. You are onboarded onto a project and you are told to go into your config management system and check out all the requirements that are there. And you are going to see a document with probably hundreds to thousands of requirements. And your job is to implement the server backend, which facilitates communication with everybody, say. Well, if you look through just a list of written out requirements, you might miss out on some of the finer points, right? Because you get very, very focused on that level of detail. But if we visualize things, we see interfaces, we can see APIs, we can see who hooks up with, which component hooks up with which component to enable communication, for example. So you can get a picture. And that's very, very helpful. I guess with this visualization too, let's not forget how useful it is to be able to talk about your project with non-technical people, right? Whether you like it or not, this class is training you to be engineers. Even if you are going the computer science route and you don't think that you are an engineer, you are. Don't worry about it. Um, if you need to talk through your project with marketing, with HR, with the business department, or maybe your users, having a model is much easier to talk about than a set of requirements, for instance, or a set of test cases. It's very good for enabling communication, basically. And with these two, we can specify the structure and behavior. Again, we have models for that. We can also use them to develop templates too. So one of the things with UML is that it is a very well understood specification. So when I harp on you all for correctly building a UML model, like I know some of you lost points on the use cases because you drew the wrong, like you drew boxes instead of ovals, for instance. I didn't take out a lot of points, but just enough to let you know you did it wrong. Um, you can feed these models into some tools. Those tools will auto-generate code for you or will auto-generate documentation. And it requires that you follow that spec for how to build a model. Okay. And let's say that you're starting off with class diagrams or use cases. You put that into Eclipse because Eclipse seems to be the go-to um, IDE for UML for some reason. I think IntelliJ's made some headway in that too, but there seems to be a ton of Eclipse plugins for this. But I build a class diagram in Eclipse, and I click Generate Code because there's a plugin for that. It will generate all the function stubs, all the classes, all the parameters that you need for the system. Now, that particular approach isn't going to fill in all the blanks, right? You have to put in the fine details and all that fun stuff. But you can get stubs, you can get half of your work done automatically through a tool. There's some debate on if that's actually good or not. It doesn't always generate the right code, but it's possible that you can use this to step things out. And then last here, we can document things, right? Don't ever discount the power of documentation for a project. Having something that you can point to later on for why we made a particular decision, it's very, very important. Consider it the CYA acronym here. So always make sure you keep that one in your mind as you go off into industry. But make sure you have reasons for why you've made decisions. So question to you, and then looks like we'll wrap up class here. So everything we're talking about UML wise has a reason. Are there models outside of software engineering? Is there anything else we can use? So pretend you're a civil engineer or a graphic artist or not a programmer. Do other domains have models? I'll end the stream once I get an answer. Or at 9:50, whichever comes first. Blueprints. There you go. Absolutely. That's a model, right? Um, it can be a specification, but technically it can be a model. Sure. So you can get 3D visualizations off of your blueprints as well, right? If you're doing something in CAD or CAM or something like that. Yeah, absolutely. CAD drawings. Maybe you're a graphic artist. You build up a 3D model of a player and you get them in their nice T-pose while they're rigged with the skeleton, right? Scripts like for movies, sure. Yeah, I mean, movie scripts don't always have the nuance of what goes into it. I mean, it's kind of a spec in a way, but it still can be a model, sure. Basically, the key here is that this is not a new idea, right? Modeling is done in every domain. It might not have the level of detail that you need for, say, a pure implementation, but it serves a different purpose. It's visualizing and it's documenting and it's showing behaviors and interactions. things that you don't necessarily get with requirements, which is our golden standard for development. Anyway, we will continue on with UML next time. But for then, or until then, have a great weekend. I'll see you Monday. If anybody needs any help, office hours start in 10. And yeah, have a great day, everybody. See you Monday. Ooh, wait, gotta have some nice weekend music. It's Mario and chill. Ooh, you know what? You guys can all leave now. I just want to test something really quickly. Because if I am in this new setup here, all right, let's get out of presenting. This is no longer part of class, by the way, so feel free to head out. I wonder, can I full screen now? Hey! Look at that. Maybe this is what I need to stream full screen stuff now. Can we do Rocket League? No, this is the question. Maybe. Screen goes black. Trippy. Wow. Does it work? Wow, it does. Neat. Look at that. I might have to do that someday. Maybe this Windows update was positive in disguise. All right, you all have a wonderful weekend. Thanks for playing along. Bye, everybody.